So you're building an electronics project, and you need it to remember things when the power's out. You've probably heard of the two heavyweights for this job, EEPROM and Flash. They might sound kind of similar, but trust me, picking the wrong one can seriously mess up your device down the line. Let's break it down and figure out how to get it right, every single time.
Think about it. What happens if your smart thermostat just forgets all your settings after a quick power flicker? Or a remote sensor loses a whole week of data? That's the exact nightmare that non-volatile memory is here to prevent. It's the secret sauce that gives a device a permanent memory, a way to hold on to the important stuff even when the lights go out.
All right, so how do we solve this memory problem? Well, for most of us, the choice really boils down to two main players on the field. You can think of them as specialists, each with a totally unique skill set for remembering things. So let's meet our contenders.
First up, we've got EEPROM. Yeah, the name is a total mouthful, but the idea behind it is actually beautiful in its simplicity. EEPROM is all about precision. It lets you read, erase, and write your data one single byte at a time. It's like having a digital notepad where you can go in and surgically change one letter on the page without smudging anything else.
And in the other corner, we have flash memory. Now, Flash thinks big. It's built for packing in tons of data. But unlike EEPROM's laser-focused precision, Flash works in big chunks. We call them blocks or sectors. So it's less like that notepad and a lot more like a giant whiteboard, where you've got to erase a whole section just to change one little thing.
And this right here is the single most important difference between them. This one distinction, byte by byte versus block by block, is the root cause of pretty much every single trade-off we are about to dive into, from speed and lifespan all the way to how much it costs. Okay, so with that core difference locked in our minds, let's put them head to head. How do they really stack up on the things that actually matter when you're building an IoT device? Let the showdown begin. So let's circle back to that write style. With EEPROM, if you want to update a setting, it's super simple. Find the byte, change it, done. But with Flash, it's this whole three-step dance. You have to read the entire block into your microcontroller's RAM, change your one little byte there, then erase the original block on the chip, and finally write the whole updated block back. That is a ton of work for one tiny change.
And that overhead directly smacks into performance. So, which one is faster? Well, it totally depends on what you're doing. For that quick one-off configuration change, EEPROM wins hands down. But if you need to save a huge log file or stream a bunch of sensor data, oh yeah, Flash is the undisputed champ. Its ability to write big pages of data all at once gives it incredible speed for those bulk jobs.
Now let's talk about something really important, lifespan, or what engineers call endurance. See, these memory cells, they wear out a tiny bit every single time you write to them. Now, 1,000,000 write cycles, that sounds like a lot, right? But check out this quote. If you're hammering the same spot over and over, like logging a sensor reading every 15 seconds, you can burn through that entire lifespan shockingly fast.
I mean, just look at how traumatic the impact of write frequency is. Writing to Flash once an hour gives you a lifespan of over a decade. Not bad. But crank that up to just once a minute on the exact same block, and suddenly its life is measured in months. This is exactly why a technique called wear leveling, where you intelligently spread the writes out across different blocks, is absolutely essential when you're working with Flash.
And what happens if the power dies right in the middle of a write? This is a big one. With EEPROM, you might lose that single byte you were writing, but the rest of your data is probably fine. With Flash, if the power dies during that whole erase and rewrite cycle, you can corrupt the entire block. We're talking kilobytes of data just gone. The takeaway here is pretty clear. For your absolute most critical data, EEPROM is just inherently the safer.
So EEPROM is precise, it's durable, it's safe. It sounds great, right? Well, there is a catch, and it is a huge one. Cost. Per byte, EEPROM can be roughly 10,000 times more expensive than Flash. No, that's not a typo. This table really puts that whole trade-off into perspective. EEPROM gives you that surgical precision, but it comes in small, expensive packages, usually measured in kilobits. Flash, on the other hand, gives you massive capacity. We're talking megabits, even gigabits, for a ridiculously low cost per byte. It really leads to a pretty simple rule of thumb. If you need kilobits, you're probably thinking EEPROM. If you need megabytes or more, Flash is really the only game in town.
Okay, so we've seen the technical showdown. Now let's translate all of that into some practical advice. How do you actually pick the right memory for your project?
Here is a super simple checklist to walk you through it. First off, how much data are you actually storing? A few bytes or a few megabytes? Second, how often are you going to be writing to it? Once a day or once a second? Third, how stable is your power source going to be? And finally, do you need to write or read big chunks of data really fast? I guarantee if you answer these 4 questions, you'll almost always land on the right solution.
All right, so let's run through a quick scenario. Let's say you need to store small but absolutely critical pieces of info. I'm talking about things like Wi-Fi passwords, device settings, calibration values, or maybe a counter for how many times an error has happened. This stuff is small, but it has to survive a reboot no matter what.
For that job, the choice is a no-brainer. You use EEPROM. Its precision, its high endurance for individual bytes, and that power failure safety we talked about make it the perfect tool for protecting those vital little nuggets of digital gold.
Okay, different scenario. This time, your device needs to log thousands and thousands of sensor readings. Or maybe it needs to store big firmware files for over-the-air updates, or even run a whole file system. We're talking about large volumes of data that need to be handled efficiently.
For this kind of bulk data storage, you guessed it, the answer is Flash. Its low cost and high density are exactly what you need for storing huge files and massive data logs without breaking the bank.
But here's the expert move, the thing the pros know. The choice isn't always either or. In fact, in a lot of the most robust designs out there, the best answer isn't to pick just one, it's to use both.
This is what we call the hybrid approach, and it truly gives you the best of both worlds. You use a small, super reliable EEPROM that acts like a safe deposit box for all your critical settings, and then you use a large, cheap flash chip for all your bulk data logging and file storage. This design pattern is basically standard practice in really demanding fields like automotive and industrial systems where failure is just not an option.
So if you remember one thing, let it be this. Think of EEPROM as your precision specialist, carefully and reliably handling a few precious, critical bytes. And think of Flash as your heavy-duty workhorse, built to move massive amounts of data quickly and cheaply. It is all about matching the right tool to the right job.
Now that you get these core trade-offs, you're totally equipped to make a smarter, more reliable choice for your own projects. So with this framework in hand, the only real question left is, what is your next great idea going to need to remember?